Welcome to NX for Manufacturing Tech Tips. This is an NX CAM tech tip on how to create a CAM component for your reuse library. We're here with Mike Menino, one of our CAM experts on the East Coast, and Mike's going to do the demonstration today. Hi, Mike.
Thank you, Aaron. Last time out, we had a discussion on how to install and use components in a CAM reuse library. In this short, brief demonstration, we're going to show you how to create a component and use in your reuse library. First thing you need to know is that it is driven by Excel. This way we can manipulate the model easily enough just by changing a few variables in a dialog box. Your design intent, you need to know up front how you want the model to be designed, what your parameters are going to be called, and how you want to use those to manipulate. So in this example, I want to create a ring that can be used behind a part in a lathe to take up space in chuck jaws. So I know I would have to have an outside diameter, an inside diameter, and a width of the rings. And maybe we have different size rings with ODs and IDs and widths. So maybe we have a few that are 2 inches in width with a 1.5 ID on all of those. And maybe the width of 1/16, 1/8, 3/16, and maybe 1/4 of an inch. Now we might also have more than one size rings, but having the same width. So we might want to just copy these and paste and just go ahead and make a few edits. Maybe we'll make these 2.5. So this database will be able to create 8 different rings with different IDs and widths and ODs. At this point, I'm going to do a file, save as, and we use the Excel 97 2003 workbook version. And I'm going to call this ring. And this gets saved into the same directory where all your files reside in your CAM reuse path. At this point, I'll come into NX, create a new model, and I'll start by defining the expressions inside the model that we just created inside our Excel. So on the OD, 2 inches on that. The ID 1.5 and the width of 0.0625. We do this so we're able to use these expressions to create the first part file. From here I will start creating my model, and I'm going to start by creating a cylinder for the outside diameter in that direction. And we want the diameter to be a formula, and we're going to let that be the OD. And we want the height to be also a formula, so that's going to be the width. And OK to that. Now I want to create the hole through the center of it to complete the ring. So I want this hole to be, once again, a formula, and we're going to call that the ID. Right through the center of the part. Maybe we want to put a chamfer on it. I'm just going to go ahead and window around the entire part and let it do a 15 thousandths chamfer. At this point, the part file is finished modeled. I'm going to do a file save as and place that in the same folder structure. And give it the same name, ring. Now if we go into our CAM reuse library, the hardware for setups, it's in here immediately. But right now there's no, if I switch over to knowledge enable, the ring disappears because there's no knowledge built into the component yet. So we have to create knowledge into that component. So at this point I'm going to tell it to create a KRX file. And what this is going to do, we're now going to link the Excel spreadsheet with the part. And I want to use the ring Excel. And it brings me a list of the variables. I want to select the ones I want to use to drive the component. And now it is knowledge enabled. When I switch back over to knowledge enabled, you should see that the ring is on the list here. We do a file save. We'll exit out. Create new NX. Now we go to add our ring. And here's where we can choose our different diameters, different widths. And now we could just assemble that into our standard cam assembly and use it for any use now. What I also want to show is some more complicated, more involved things you could do with this. So if I say my 3-jaw chuck, I'm just going to go ahead and open that file from here. How you could drive more complicated parts. So right here, if you look at my chuck diameter, we're using if-then expressions. It's saying if my chuck is less than or equal to 6 inches, we're going to use the 8-inch chuck. And if it's greater or less than or equal to 8 inches, we're going to use the 10-inch chuck, else we'll use the 12-inch chuck. So if I come in here and change my clamp diameter to maybe 4, the chuck jaws move out accordingly. But if I go to 6.5 now, not only do the chuck jaws move out, we switch to the 8-inch chuck. And that's all I have to show today. Thank you.